fire triangle. And the fire triangle, not to be confused with the fire diamond or the hazard diamond, is essentially just what you need to create fire, combustion. Alright, you need fuel. This is what the stuff actually burns. You need oxidizer. So like fuel, well, let me go back here. Fuel would be something like gas or something like wood. You need oxidizer. And this is also important for stuff to burn. And now, things can only really burn because there's oxygen in our atmosphere. And you need ignition. You need a spark or you need some heat to start that fire. Yeah, this might get a bit confusing because fire triangle, fire diamond. This shouldn't really be called the fire diamond because only this top part right here is reflecting on fire. This is, the blue side is, I want to say, health hazard. This yellow side is chemical reactivity, and the white bottom part is extra just other warnings. This part does reflect on this part. So it's a fire triangle is a square in the diamond. So let's get an example of this stuff. So you need fuel, which would be in this case wood. And then you have this oxygen in the air. You have a spark. You have ignition from, say, lightning. And you have fire. But because the oxygen is in the air, it can be smothered, with, say, a blanket, like a fire blanket, like water, and it's pretty much gone. This is why, technically, why you can't have fire in space, for example. There's no oxidizer in the air to allow that fuel to combust. Now, you might say, oh, well, how do rockets work in vacuum? And that's because they have non-atmospheric oxidizer helping them. So say you were to mix up some sugar and some KNO3, which is potassium nitrate, which is sort of a pretty good oxidizer, and you use your lighter, and boom, you have a fire. And this one, since the oxidizer is in here, the oxidizer right here, is in here, you can't be smothered. It's gonna stay there until it eats up, fire eats up all the oxidizer and the fuel. Now, let me show you some quick stuff to show you guys. So here we have a candle, right? Now, this, the wick right here, and the wax, these are our fuels. The candle fire eats it up. Here we have a fire, which is very efficient. So, and then the air all around us, that is our fuel. Or our oxidizer, sorry. So let's start that candle. And we have achieved combustion because all three requirements of the triangle are met. So, there we go. Oh my god, that's a powerful fire today. Can't start anything. Guess extra fuel or something of those likes. Extra oxidizer. Now the fire. Now, of course, the fire eats up the fuel. It's burning. Not really eating it up because of conservation of matter, but it's turning it into this fuel, the wax here. I'm not sure if it's paraffin or beeswax, and it's vaporizing it. And that's how it's getting fired, and it's taking away some oxidizer. And you see proof of how it eats that fuel is because eventually, like a log on fire, eventually it's fully carbonated. Can't be burnt anymore. Ash, pretty much. That's whatever. And if you have like a rocket, it also eats up the oxidizer stuff. I think that burns up with gas. But the oxidizer, let's say, fire eats stuff up. So say I took this lid and I've enclosed it. Now watch what happens. It's quite peculiar. It's starting to darken and the fire's out. Because there's no more oxidizer. It's starved. It's starved itself. All that smoke that it's making. That not too bad. It's not. This kind of smoke's not too bad for you. No more. Oh, my iPhone. Smoke smothered it itself. It didn't allow it. It blocked it from getting any more oxidizer. Let's watch that again. It's not happy with me, but we have our fuel. It's eating out. It's slowly melting away at that wax. Okay. Smother it from its oxidizer. I don't know if it really eats up oxidizer. I guess it does. Kind of burns it away. But in this case, the reason it's because it's smothering itself with its own smoke from the burnt fuel. So cover it and then watch it. The fire dims and gone. But you can see it's quite foggy in there because of all that smoke. And all that smoke comes out. This bad boy right here is pretty hot. So, yeah, that's an interesting thing. A lot of incense in here. Maybe it's not incense. Maybe it's real cancerous. I don't know. Whatever the smoke is. Hopefully it's fine breathing it in. But that's what it is. Pretty interesting.